carrying on like an idiot. When we talk about simple machines, when I ask you, for example, a screwdriver, and people tell me a screwdriver is a pulley, okay? It tends to upset me because you have to recognize certain things. So in your notes yesterday, when you filled out your chart, if we have pulley, find your notes from yesterday, first of all, okay? Because I'm going to ask you these things tomorrow on the quiz. What are the key things you have to look for to be a pulley? It has to have two things. A wheel and a rope. Now, it doesn't have to be literally a rope. It could be a chain. It could be a cable. It could be a rope. But it has to be some kind of cord that will wrap around a what? A wheel. Okay? So, up here where it says, what is the key to identifying each type of machine? For a pulley, you have to know that a pulley is a wheel and a rope. Okay? So if I say a wheelbarrow, do you know how many times I've been told in the last 20 years a wheelbarrow is a pulley?
No, a lot.
A lot. Now, and perhaps it's just because people aren't exposed to a wheelbarrow, that you guys just don't do any kind of gardening. You don't have to move anything in your yard from one place to another. Maybe you've never been to Lowe's and seen a wheelbarrow. Y'all seen a wheelbarrow?
Yes.
You know what I'm talking about when I say a wheelbarrow?
Yes.
Where is the rope?
No, I haven't.
Me either. Okay? That is my confusion about some of these things. When I say that I get upset when people tell me it's a pulley. Okay? It can't be a pulley unless it has a wheel and a rope. Well, I don't know. All right. What about the wheel and axle? What is the key to being a wheel and an axle?
A wheel and hole through the wheel.
Okay. It has to be a wheel and a rod. Okay. So you have to have a wheel and you got to have a rod that goes through the wheel. If there's no rod that goes through the wheel, it's not a wheel and an axle. Okay. How about a lever? Or you can say lever. Okay, what do you look for? It has to be a stiff bar. Now, there is also typically going to be a pivot point. I'm just putting this up here. And it has a fancy science name. It's called a fulcrum. You guys are all using one right now if you're actually participating in the opening. Okay? A pen or a pencil is a lever. This is a stiff bar. Okay? It doesn't have to be a long stiff bar. That light switch, when I turn it on in the morning, is a stiff bar even though it's short. Okay? It moves up and down. It's an extension that I can toggle up and down. Now, the pivot point is wherever it's attached or doing the work. So for y'all, the work is being done where? At the pencil point. That's the pivot. On the light switch, it's where it's attached to the wall and I can toggle it up and down. Okay? But basically, it's a stiff bar. Now, for what other ones do we want to do here? What? Inclined plane. The inclined plane just has to do what? Let's look. Think about inclined plane. Has to go up. Okay?
Stairs. Around.
Basically, it's to raise something. All right? So yesterday, one of the pictures that we had was the tornado slide. I don't know how many of you put that down under inclined plane, but the tornado slide, or if you've got it, it's the slide that goes in a circle as opposed to straight down. The tornado slide is an inclined plane, right?
Yeah.
Anybody put it under screw? Okay, I had a few people who asked me in fourth period could it go under a screw because it has it. Okay, let's talk about the definition of a screw.
No, it can't. Because it's on plane wrapped around a pole with hose.
Okay. It's a pole with an inclined plane wrapped around it.
Yes.
Okay? So if I take probably have it under here. I do. Just need that crap. Can we agree that's an inclined plane?
Yes. Yeah.
Okay. Here's a pole. Not a very good pole for what I want. Alright. Wrap it around. Works better when my fingers actually work. Practice. Okay. When I do this, it's much easier to see up close, but you can see that there are lines all along here from the paper. And the paper lines look very much like the lines on a bottle top or the lines on a side like a screw or a pole. Okay? So, a screw is a pole with an inclined plane. So, several people before said, why can't the tornado slide be a screw? All right, what's the purpose of a screw?
The whole thing together.
To hold things together. Okay? So, even though you know the definition of a screw is possibly a pole with an inclined plane, you know its function is to hold something together. Whether it be a lid on a bottle or something attached to a wall, it holds it together. Does the tornado slide do that?
No.
No. It's designed to raise you from the top of the slide to the bottom of the slide. Okay? So that's why the slide is not considered a screw. All right? What's the one I'm missing?
A wedge.
A wedge. Okay? The wedge is the one I think is the absolute easiest. What do you look for to be a wedge? All right, it's going to be an inclined plane. All right? It's going to look like an inclined plane, but it needs one more piece. What else do I need to add to that?
Sharp.
Key. That's it. It needs a sharp edge.
Scissors.
Yes. Scissors are a great example. Okay? The key is it has to have the sharp edge. So, again, the tornado slide is an inclined plane, but is it a wedge? No, because it doesn't have a what on it? It doesn't have a sharp edge. So a lot of tools are going to fit in more than one category, okay? Based on what they are and what they look for. But those are the key things that you should be able to tell me based on what we did yesterday, okay? So nobody should tell me things are pulleys unless they have wheels and they have ropes. That's not your go-to answer, by the way. If you had no idea, none, what do you think the best answer choice would be to guess? Any ideas? Most common type of, most common type of simple machine up there.
Wheel and axle. Lever.
It's a lever. Okay? If you have no idea and you're just taking a blind guess, most common is a lever. All right? So, if we go back, now to number one. What's a drill bit? It is a screw. If you look at its sides and the way it's designed, first of all, it has sharp edges. You could argue it's a wedge, but it's not really a wedge. All right? But it has screws so that it can bore through and drill into things. A bicycle wheel.
Wheel and axle.
It's a wheel and axle. It's round like a wheel and has a rod through it so it can attach to the bicycle. Stairs are a inclined plane. They raise us from the bottom to the top or the top to the bottom. A hammer.
Wedge.
One answer.
Lever.
A lever is the other answer. Okay? You can put either answer. Your hand is the pivot point or the fulcrum. The stiff bar is the handle. So you could have put lever. The wedge would be the what part of the hammer?
The backside.
Which would be the, other than saying the backside, it's got a name. Starts with a C. Called a claw hammer, as opposed to a ball pin or ball peen hammer. All right, a knife would be a
Wedge.
most people list it as a wedge. You could argue that it is a what? You could argue that it's a lever, because it is. All right, mini blinds.
Pulley.
That's a pulley. You pull a rope There's a wheel in the top that winds the rope up and allows the blinds to go up. You pull them down, it allows the ropes to let the blinds down. Okay? Questions? What's a doorknob?
It's a
It's a wheel and axle. Okay? There's a pin that goes through the wheel that allows the doorknob to turn. Okay? I get pulley locks for that one also. There's no ropes in doors.
You said it wrong.
What?
When you pull the rope down, the blinds go up.
Oh,
When you
sorry.
the-
Gotcha. Well, thank you for fixing that. All right. Questions about what we did yesterday?
That's not necessary.
Harris is in the annex.
And
Yeah, annex. She's in Ms. Van Landingham's old classroom.
Thank you very much.
You're very welcome.
Hey, Sergeant.
All right. We're going to do a Kahoot next, so I need keys to unlock the card. I have some of your folks in here. I have Virginia, Raoul.
Sad case.
All right. Who's table? That one. Right there, just make it easier. Well, I'll have to worry on pull the doors off. All right, grab your laptops. Everyone need to call, Pastor? Take it to death tonight.
Walk out like this.
Yes.
What are you doing?
No.
Hey, William, and Caleb were on the track.
Yeah. Rebecca.
You remind us what guys are going on.
I didn't bring that dress yet. Even though you gotta wear safety pins.
You got to the left. It's fine.
Yes, we finished. What was the last day you were here? Friday and Monday.
Really? Yeah.
Stay with me.
Who got number 4?
Somebody take 4?
In the wrong spot. There are numbers on it.
Come look at this.
Oh, well, they told me to come up there today, so I'm going up there today.
Come here.
Like I said. Oh, well, like I said.
I'll stab you.
Oh, well, they told me to go up there, so.
Well, that's a phone cover of that number. Like, that's one that's a hard to take. It's not right. It didn't take that long. It didn't take a long. Yeah. What? That's not right.
Go! No, if you die, I'm gonna stand at your casket and rest is pregnancy.
That's weird.
What?
Wait, yeah, she said, I did not say that.
Man,
Yeah, my dad.
He said,
I said, you die, I'm gonna, pour beer in your grave.
No,
What you got now?
That's not gonna wait when we
he can't even pull it out.
I thought you said you got Andrew.
Hey,
I'm pretty sure.
You.
If I die,
It's okay. Sorry, I said.
Shut up.
Tomorrow.
See, you never.
I didn't even say anything.
What would be hitting all the bills? Boy,
Is that right? Is that right?
We're only gonna see kids in finger places.
Yeah, I didn't do it like that.
We're the one gonna get.
It wasn't all dude.
It wasn't dude.
No, it wasn't. All dude. Clear your ears out. You don't listen.
You said it was.
Virginia, she's back. Go quickly.
You get like that. Girl, when you with the love, she gonna clean something out.
Now put your real names in. Don't make me kick you out. William, really? You can't just put your name.
I didn't put my name.
That's his whole name.
That's their entire name?
Yeah, actually it wasn't. I missed off 3 letters. Really?
William, yeah, the full of you.
It won't let me in now.
Who is this then?
You got the code name.
Name's Jeff. Who's Jeff?
Not a clue.
Y'all just put the name in.
Put William's name.
Right there.
I already eliminated that one.
I was gonna put cocoa butter boo boo, but no. Cocoa butter boo boo.
Alright, I think we have 19
Oh, Sacramento's
because we're missing.
Sacramento's not.
Sacramento's not
Who
in.
put that? Why I gotta be a thought when I'm doing? They beat me up and shoot me. I'm sorry.
Alright, this is very similar to what you're going to have to do on the quiz tomorrow.
Hey,
Okay, hold on up here.
jumping up.
And what? 2304076. Alright. Slanting surface from a higher to lower level is an inclined plane. I'm not going to tell you what any of the other 3 are because they're in the next couple questions.
Beaton.
That's you.
I'm 4 points behind William.
Alright, those of you who picked wheel and axle and wedge, pay attention to the next couple questions. Alright. First who picked inclined plane. We already said it was a slanting surface, yes. But the sharp edge rules out inclined planes. They're not sharp. And the 2 of you who picked screw, I think that's in here too.
Right. I picked mine on accident. Some of y'all picked y'all's because y'all don't.
All right, so wheel and axle has to be a wheel that has a what through it? A rod.
A rod.
Okay, pulley has the rope. Oh, let me write something down real quick.
Let's see that. Let's see that kill streak. And that full kill streak.
Yeah.
Bless you. Bless you, bless you, bless you.
I'm sick. Yeah, I know.
Yeah. Okay.
Some girl like
A screw.
Yeah. Remember the pencil?
Mhm.
Yeah.
Pencil. Oh, pencil with 11.
All right.
Oh, you mean paper.
Pencil, inclined plane, wrapped around a pole. Okay. That's a screw. All right.
A wheel with a rock. A wheel.
All right. So that was better. We just had this one like 3 questions ago, people. All right. Which one's an example of a lever? Somebody let Virginia in.
Oh, I thought it said just a bottle.
All right. So, following is an example of a lever. It must have had a picture.
Elevator is.
I need a picture. Oh, way.
They didn't.
Oh, they've got that. Okay. So, a wagon. What a wagon be? I'm almost afraid that I use these same examples in further questions.
Wheel and axle.
That's a wheel and axle. It has wheels under it. A bottle top would be a what? And an elevator.
Pulley.
Okay. Probably the next question because I don't remember it well enough. There you go.
You just told us that.
That's why I said it's probably the next question.
I know you'll get it right.
All right. So when you look at that one, the two of you who picked blue and green, or sorry, red and green, I'm really hoping you just weren't listening. Or you accidentally hit something on your computer by mistake because I just told you the answer. All right. A bottle top is a screw. Mini blinds are examples of what? People will actually tell me that sometimes.
Okay, now look like
All
that.
right. Mini blinds are hanging in the window.
I ain't gonna lie, I almost picked diamonds.
What?
Okay, the incline plane. I need help. I don't understand why people pick that as an incline plane. Because they go up and down? I mean, I don't know how to fix it because I don't understand it. Okay? Pulleys have what inside, or pulleys have what in them? They have wheels and they have ropes. And maybe the problem is because people just don't have mini blinds anymore. Okay? You guys have mini blinds at home? I have mini blinds at all my windows. I don't like people looking in. All right? So, I have curtains on several windows. So, when
What do we got wood on?
my husband would have the back gate if I allowed it, but I like sunshine. So when you look at mini blinds, they have strings. They have ropes that run through them to raise and lower them. And there are wheels inside that turn. So I'm thinking people have seen those before, but maybe that's where the disconnect is and y'all just haven't seen those. Okay, but an inclined plane has to be slanted. Are mini blinds hanging in a slant? No, that's why it's not an inclined plane. Okay, an inclined plane has to go up and down and it has to be slanted. So when we look at stairs, stairs are slanted. We can't have a set of stairs that go straight up. That'd be a ladder, but even a ladder usually is going to be at a what? It's going to be at an angle. Okay? All right, a doorknob. If you were listening earlier, we talked about this one. Yes, I did. Because it's often misunderstood. Because most people have not seen the inside of one, so they don't know.
I mean, I always thought it was a lever. I ain't gonna lie, I thought it was a lever.
Think it's screw.
All right, it's a wheel and axle.
Okay,
Okay, it's not a screw. There's nothing inside that's holding something together. Now, one of the things you can also think about is what is the function? Okay, screws hold things together. Doors and doorknobs aren't meant to hold things together. The pulley, there's no rope. And a lever, at least that one I can work with. The lever,
Yeah,
technically, I can argue that one's correct.
Yeah.
Okay? But the screw and the pulley, they're just not right. Okay? Now, at this point, you hopefully know the definitions. All right, don't close. The definitions for both. Just stay there. The 6 types, and you should also be able to recognize examples. That is the quiz tomorrow. Other than one question on math that we're going to do today. Okay, one math question. So we're going to use ClassFlow today. So I want you to go to classflow.com/student. Okay, classflow.com/student. I usually use Learner. In the workshop I went to last Monday, they use students. We're going to try it for a minute and see what happens.
What's the code? No trade.
I got to pull it up. I got to log in. I think I can remember it, but I can't swear to it. I think it's Q3KHR. I don't want that one. The resources. Gives me some kind of cleanup. Ooh, that's wrong. All right, Q3HFR. I was in the ballpark.
Close.
I was guessing.
Q3HFR. Now, today's notes are pretty technical. We're going to do inclined planes. And hopefully we'll be able to start on levers. If we don't get to levers, I can cope. All right? But your name's not in there unless it kept it from last time because I haven't put it in there. So just type your name in. Everybody getting in okay? And then find your notes. Okay? You're going to need notes and your laptop today. We're going to go back and forth between the two. You what? Your notes right here.
So, what's the name of it?
Yeah, you need your notebooks to take notes. Y'all are taking notes today with the computers, and you're practicing with the computers. I know there's not a lot of space on your desk. Yes, Logan.
Thing. The note, how would I
Do what?
or you just name it? IMA.
IMA. You can name it. That's what IMA stands for. That's what we're already talking about. You want to do what?
All these stuff are plastic.
All right, I closed it out so we can go back in. Anybody else having trouble?
As well.
Yes, ma'am.
Can you send Jemima over to the office? She's signing out.
I will.
Thank you.
Why are you signing as me?
Boy.
Huh? Okay. You spelled your name wrong. You should be able to log out. Okay? Because you're not signed in as anybody. Go back into classflow.com/student. You want the homework done? One second. And when it comes up, it's going to ask you to type in your name. Go all the way to the bottom. And we'll type in your name. You shouldn't be me. So I'll show you this side.
You know what?
Here you go, Janai.
You know what? I told you. Wow, already. You know what? I told you.
Alright, so we're essentially doing page 1,
Oh.
page 2, page 3.
I say you don't get out lunch.
And I'll post it on the website after class. Alright, Raul, we got the phone, we'll type your name in. All the way to the bottom. Thank you, Raul. And then, there you go. Now you don't say me. All right, Logan, take your earbuds out. Where you put your phone. All right. Now, everybody get it? Now, don't write for a minute. Okay, just listen. I'll give you a chance to write in a second. Okay, but rather than me going between ClassFlow and Smartboard and back and forth, because half the time I have to reload and relog in, which drives me nuts. Okay, just listen for a minute, and then I'm going to shut up so you can write. And everybody do that. Okay. Now, we're going to learn to calculate with 3 formulas today. All 3 formulas are on your reference sheet. You have to learn to do this with 2 types of machines. Okay? We have to learn to do it with levers or levers, however you want to say it, and inclined planes. We're going to start with inclined planes today, and then if we have time, we'll start with the levers. If we don't have time for levers today, we'll do levers tomorrow. Okay? The formulas are identical for both machines. You just have to learn how to use the formulas. The formulas work like every other formula we've ever done. Okay? The hard part for people in these formulas are remembering what's effort and what's resistance. Okay? Because you have to know on an inclined plane what's the effort and what's the resistance. Okay? And that part you just have to learn. Caleb, you need help? Just little thing, we'll do it. All right. Now, we're going to talk IMA first. Okay? All right, just listen and look. IMA is going to be abbreviated for ideal mechanical advantage. Okay? And that's a pretty technical term. All right? It means a simple machine would be considered ideal if it had no friction. Do machines have friction? When parts rub up against each other in a machine, do they have friction?
Yeah.
Yes. So does ideal mechanical advantage actually exist?
No.
No. This is a theoretical number that we're going to calculate. Friction exists in all machines. So this IMA is considered no friction. Okay? So, when you're writing this, okay, circle or underline that we're talking about no friction. Okay? Some of the effort that's put into the machine is lost as friction. What does friction become? Anybody know? Becomes, starts with an H. Heat. Okay? That's why machines get what? Hot. Okay? Because friction becomes heat. Now, IMA is saying there's no friction, so machines are never going to do what? Never going to get hot. Is that the way it works in the real world?
No.
No. So this is a fictional number that we're going to calculate. Now, how do we calculate it? The formula is effort distance over resistance distance. Okay? Now, this right here is what's on the reference table. DE over DR. DE is effort distance over resistance distance. Y'all have no idea what those are, right? So this is what it is. This is the part you have to learn. Effort distance is the length of the ramp. Resistance distance is the height of the ramp. So let's say this is our inclined plane right there. Okay? Sort of ugly, I know. This right here would be length. So that's what? That's the effort distance. That's going to be your DE. This here is height. That's going to be your DR. Okay? And I'll give you a minute to write all that down. What cleaner did you use? Oh, that stuff is strong.
What?
Does anybody else smell like cleaner besides me?
I smell
Sheesh.
You that good stuff.
Hmm?
You use that good stuff.
I don't know if it's good stuff or not. I don't know if I send it again if the writing will appear. I don't think it will. Any of the writing come through?
No.
I didn't think so. I didn't think it would. All right, but you've got this stuff right in front of you to be able to write down your notes. You're going to need it. If nothing else, you need to write down this in at least one example. Because in a minute, you're going to calculate and send stuff back to me. Are we done? Well, now.
Yep.
All right, so if we look at, okay, all right, this one, okay, I labeled a picture to make it easier for you, okay, without my terrible drawings. So this is a typical inclined plane, right? Let's say we're trying to move this box up an inclined plane. This is the length of the ramp, right? So I labeled it as what? D what? That's effort, okay? The length of the ramp is always effort. And I can't do anything for you except tell you you got to learn that piece. You got to memorize it, okay? The formulas are given, but labeling the effort and the resistance is not. You got to learn that. Now, the height of the ramp is always your resistance. So from there,
You, 15 by 12.
okay, so IMA is effort distance. My effort distance is 15 meters. My resistance distance is
12 meters.
12 meters. Now, somebody divide 15 by 12 for me.
1.25.
1.25?
Yeah.
Now, tell me what's going to happen to my units.
They're gonna cancel out.
They're going to cancel out. So what unit is IMA going to have? None.
I was gonna say,
Okay?
hey,
There's no unit on IMA. So all of you folks who keep forgetting your units, I have good news for you on IMA and AMA. There's no unit. Okay? So once you get the 1.25, you have your answer. Questions? Good. Oh, did I need to wait? Are people writing?
Yeah.
I didn't want to rush anybody. Okay. I'll wait a second while you get it. And when you got it, Nathaniel.
Good.
Okay. All right, so when we look at this next question, all right? Whoops, I don't like that. Like this. All right, did you get it? Did you get tools?
Yeah.
All right. Yes, no? No tools?
Nope.
All right, let me try it again. All right, now you got it?
We got it.
I got it. Now just click the wrong button so I can go apparently. All right, find me an answer and send it back to me. You didn't get what? I would say go out and go back in because it should have come to you. Or you can just hold on and I'm getting ready to send another one and let's see what happens. All right, so we check to see what we've got. We've got 10 responses remaining. Good Lord, people. You've got a response. You need to get it up here. Now, as we move through this and we get towards efficiency, I'm going to want some work. Now, for those of you who cannot use the mouse because it's a pain, you can do the work on paper and use your camera to take a picture of it and send it to me. You do not have to do all the work with that pen and the mouse. Okay, there's nothing wrong with and working it and then sending me a picture. All right, so if I hit stop, let's see what we got. All right, 20 over 8 is 2.5. That one's correct. We got a lot of those. Those all say 2.5, 2.5, 2.5, 2.5. It looks like everything I can see is 2.5. So we should be good to go on that. All right. So let's try one like this. Okay. Now, what if, draw a picture. What if they give you words? Okay. So let's say I send you this. Everybody get it? Raul, did it come this time? Yes? I got it. All right, this time I sent you words, no pictures.
Everything.
You got it? The picture? It's not hard to do it that way. You can send me your work. You don't have to fight with the mouse. Particularly when we do things like efficiency in a few minutes, which is going to be hard. And this one's pretty easy because there's only 2 numbers to work with. All right, so if we check out some of what we got, send what you want because I'm getting ready to hit stop. All right, so we got some 3.33s here, which should be the right answer. All right.
Oh, I just got knocked out.
Sign back in. All right, so you can see somebody drew it. We've got 10, 3, 3.3. Showed their work that way. We've got that one. Showed their work that way. We've got the calculator. Not sure that shows a whole lot, but okay. We've got several people who did this, which looks nice also.
I did that.
Looks nice.
That's not wrong.
Okay. I mean, I can click show names and I can see all the names, but I don't want anybody's names up here at the moment. All right. See what you can do with this. And then we're going to switch to AMA. Yeah, last one, then we're going to AMA. Question, Ms. Cheese? This ought to be killing you if yesterday's was really hard. Did you not get it? Solve that. This time you have to find one of the distances. Well, how many answers up there yet?
That's it, mine.
Maybe it's because I split it up or something. Well, I don't see anything. See the question.
Messed up.
No, it says 8 responses remaining. I just don't see any answers, any cards.
Stop the poll. Or right beside the arrows at the bottom.
I think that's to add a card. All right, let's hit stop. There's, I want to add text. Wait. Go there and go back. There we go. All right. If I pull this one up, what's the effort distance? What's the effort distance on a ramp if the ramp is 4.5 meters high with a mechanical advantage of 3.2? All right, I got an answer 1.4 on that one. All right. I got 14.4 on that one. I got 1.4, 14.4, 14.4 on that one. I got a 7.1 on that one. Okay. 1.4. It looks like all of them are 1.4 or 14.4.
14.4.
That's not what I wanted. All right. If you think the answer is 14.4, put yes. If you think it's not, put no. So I should essentially yes, no. Okay? If you think it's 14.4, put yes. If you think it's that 1.4, put no. Okay, I like the don't know category drawing. All right, so I got a bunch of people who think that. I got don't know. Okay. Don't know is helpful. So what? All right, so if I, whoops, that's not what I wanted. Go back here for a second. All right, let's see which one was right. All right, first of all, let's stop that. All right, we got a ramp, right?
Yeah.
What did I tell you the length of the ramp was?
You didn't say.
I didn't say it. I said it was 4.5 meters high. Okay? And I told you the mechanical advantage is what? All right, so your formula is IMA equals DE over DR. This is where all of these formulas we've been learning work the exact same way. Okay? So IMA is what number?
Is 3.2.
3.2 equals what is the effort distance? We're looking for what? You're looking for DE over what is DR?
4.5.
So what do we do with these two numbers?
You times them.
You cross multiply. So all those people who said 14.4 have the right answer. Now, does it have a unit this time?
Yes.
Yes.
Yes, because you're solving for a what?
Distance.
A distance. What's the distance unit? Meter. Okay? Everybody got it? All right, let's talk AMA. All right, so again, don't write, just listen for a minute. All right, so AMA is the real life type of mechanical advantage. This is where you do have friction, okay? So in your notes, make sure you underline or circle these have friction, these calculations. So actual mechanical advantage have friction. They will have a smaller number than ideal mechanical advantage because some of their energy is lost in the form of what?
Friction.
Friction becomes what? Heat. So some of their energy is lost in the form of heat. Yes, I was going to give you a chance to write this. Pay attention. Okay? So it's going to be lower than ideal mechanical advantage. It has friction. Everybody with me on that? Yeah. Now, its formula is not going to be distances. Okay? It's what? It's forces. So AMA is resistance force over effort force. So look at the formula. AMA equals FR over FE. Does it look similar to something we just did? What's different about it though? It's flipped. Okay? And I'm just going to write IMA here for a second. IMA is DE over DR. It's really easy to get the effort and the resistance backwards. So where should you look every time if you're not certain? On your orange card. Okay? Now, write it down, and we'll talk about how to find it. We'll do an example. Oh, I can make that easier. I can send it to you. There. Now it's in front of you. You don't have to look so far away.
I can't find my glasses. I think my brothers threw them away.
Brothers must be some gems if they throw glasses away.
Well, they knows all about my brothers.
Look at that on look. They're crazy. I know.
Okay.
That's how you know to be crazy when others seem to be crazy.
All right, does everybody have it?
No.
Okay. How about now? Yeah? All right, let me just hit save. All right, so when we look at examples here, the problems work the exact same way, except they're going to be what? Forces, okay? Now, I put spring scales in these pictures because force is measured with a spring scale. You do not have to draw the scales if anybody's actually writing this down, okay? So, the effort force is still always where? Effort is still what's used to raise it up here, and resistance is always the height are going to be lifting it. Now, when you go to calculate this, when you read the question, if it tells you that you lifted it, okay? If it describes you lifted, you lifted is always effort because you do that, okay? If it describes something else, it's probably resistance. Now, when you plug it in, 35 divided by 15, what do we notice about this answer again? What's going to happen to those ends? What's going to happen to these ends? They're going to cancel out. So are we going to have a unit on AMA? No. Okay, so let's say that we have this, and we want to find the AMA. Okay, what are they telling us? Not supposed to be up there. 35 is supposed to be down here by this scale, but I can't move it at this point without altering or editing it. So
divided by 35.
AMA is FR over FE. So the resistance is what's the block we're trying to move away. What's its force? How much does that weigh? It weighs how much? 105 newtons divided by how much would we have to exert?
35.
35. Now, what do you notice about these numbers? Which number should be smaller, the effort or the resistance? The effort. Because if we had to put in more effort than what it weighs, would the machine do anything for us? No. Okay? The machine should make our effort smaller. All right, so when we divide, we get 3. Thank you. So, do I put a unit on it? No. All right. Get rid of that. Get rid of all my writing. Now, this one doesn't have a picture. You guys find me the answer. Oh, I got to do the poll. There you go. Thank you. Find me the answer. All right. How many have I got up there?
5 responses remaining.
You got mine.
What is this scribbled out mess? All right, let's stop what we've got. Dang. Okay.
Go ahead.
It's not necessarily wrong, it's just a mess. Okay. All right, we seem to all agree. So when we go to solve this, all right, let's pull that one up since it doesn't have any work on it. All right, we find AMA is equal to, what's our effort? Sorry, FR over FE. So even I've stopped thinking about the formulas. I've done this a long time. All right, what's our resistance?
Resistance is 205.
Over, what's our effort?
55.
55. So that's a nice easy one, right?
Yep.
All right, so let's talk about something where it's not quite as easy. I don't know what that is. All right, efficiency. Okay? Efficiency is the machine multiplies force. Okay? How effective is the machine is called efficiency. All right, so you buy a machine. All right, let's say we're a manufacturing facility. You buy a machine, and it only is 50% efficient. Are we going to make much money if it's only 50% efficient?
No.
No. We want our machine to be very efficient. We want, 80, 90% efficiency, right? So efficiency is a calculation we can do to see if our machine is efficient. Now, got your orange card? I'm going to let you write down a formula. Find your orange card. If you don't have your orange card, you don't get to write it down. Those of you who've lost it, you're out of luck. Because they're not written on the spares. Dang. Not writing it on the spares either. All right. Find where it says efficiency. It's at the bottom of the front page. Down at the bottom of the very first page. Okay? I think it's pretty close to the bottom. Yep, it's not quite the bottom formula, but it's very close. Not the bottom formula, but it's almost the bottom. Now, the formula that is on our reference table is this one. Work out divided by work in, right? W out over W in.
Yeah.
This one's not there. Okay? I want you to write it down because I'm going to let you use it. Okay? AMA divided by IMA times 100. Okay? The efficiency of a machine is AMA divided by IMA times 100. Okay? You won't need it for the state test because they're not going to ask it in that fashion. But I'm going to ask you it in this fashion over the course of the next few days. Okay? Now, remember what we said. IMA is the one that has no friction. It's a theoretical number. So IMA is always going to be the what? The bigger number or the smaller number? The bigger number. So, efficiency is harder for people to calculate. This is the only formula I will ever tell you this. Okay? It's the only time I will ever tell you this. Okay? But in efficiency, the greatest efficiency your machine can have is what? 100. So, in efficiency, the little number is always on top and the big number is always on the bottom because IMA is a made-up number. It always has to be bigger than the what? Than the actual one, okay? The actual one has friction. It's going to be a smaller number. IMA is going to be a bigger number because it's theoretical. So when you calculate and you're like, dang, Miss Wall, I don't know what number goes where. I'll be the first to tell you. I don't either. I've taught this a long time. I cannot figure out a way to teach high schoolers in a way that makes sense to them. So this is the only way I can do it. A little number goes on top and a big number goes on the bottom. It's the only formula on that reference sheet that works that way, though. Okay? If you haven't written that down, write it down. This is our last formula. These are the 3 formulas we're going to use tomorrow also, only we're going to do it with levers instead of inclined planes. Okay, inclined planes are the easiest, which is why I've opted to start with inclined planes. All right, get it down so we can do a sample. You got homework with this tonight. It's not hard. They're just pictures. It should be easy. You should be able to do your homework in 5 to 10 minutes or less. Bree, you should be able to do this after work with like no time.
I'm gonna do it on my way.
It's easy. All right, does everybody have what they need?
Yeah.
Anybody need me to wait?
They kicked me out.
Who kicked you out? I won't tell you.
Oh, that's worse.
Everybody have it. All right. So, I'm going to give you a second to write this down because you're going to need a sample for homework. You got to do 2. Okay? You don't have to draw a spring scale. Just put the numbers down. Did you do the 150 divided by 45?
Yeah. And then
Okay. And so you do the
12 to 5.
yeah, that's 4. So whatever you got for the 150 divided by 45 on the top. On the other. All right. Everybody got it written down? Now the first thing you have to do is find AMA. Okay? AMA is what formula?
What?
What do we practice? AMA is what?
Force or what?
DE over
Oh, you said I know.
DR. Okay? So what's my effort? What do we look for to be effort? The length or the height?
Lane.
So 12 over 3 is 4. Okay? So that's IMA. All right, I'm going to change colors for AMA. What numbers are AMA?
150 and 45.
Okay, FR over FE. Forces. I have to have what units to be forces? Newtons. This is why I've been pushing units. As we get deeper and deeper into these formulas, you have to know the units. So the force resistance is what? How much does the box weigh? 150 over 45.
3.3.
3.3 is what Jacob says we get. Now, those are the 2 pieces we've been doing. Here's the new piece. Efficiency.
And then you do 3.3 divided by.
Shh. I know you got it. Okay? Efficiency is AMA. So what was the AMA number we got? The AMA?
AMA is 3.3.
AMA is, or IMA, sorry. IMA is 4.
3.3.
You want AMA. AMA is, so 3.3 divided by, what's IMA?
4
4,
times 100.
and then times 100.
Which is 82.5.
Now, efficiency is a percent. That's 82.5% efficient. It's not bad for an efficiency. Okay? Now, for homework, you're doing the same thing with pictures. Okay? See how they have pictures? Look at where I'm putting my hand. It says the word lever right there. I'm covering it. You're doing all of the pictures that have what? What did we work with today? Yeah, but is it inclined planes or levers?
Income plan.
Inclined planes. You're doing all the pictures with the inclined planes. You're not doing any of the pictures with levers, okay? So while y'all are putting your calculators and your computers up, I'm gonna put the homework on your desk. It's like 4 questions where you gotta calculate. Will not take you long to do this tonight. Or today, if you go break in somebody else's class. It'll probably take you 5 minutes. Calculators in the tub, computers plugged in and in the right order.
My desk. Wait.
Two here. And Hernandez was here. Hernandez, are you behind you today? John, anybody behind you today?
No.
No. Are you kidding? You've been packing up for 10 minutes. You want him to be putting your stuff away? Oh, I don't have any